Industry skills, practical knowledge, real-world impact. This is Simple Gyan.
Welcome to this engineering documentary on waste heat recovery boilers, also called WHRBs. In this video, we will understand how a waste heat recovery boiler works, where it is used, and most importantly, how to calculate the fuel saving it delivers. Here is an interesting question. Can a boiler produce steam without burning additional fuel? The surprising answer is yes. A waste heat recovery boiler uses the heat already present in exhaust gases from furnaces, turbines, engines, kilns, and process plants. Instead of letting this heat escape, it converts it into steam. A waste heat recovery boiler is a type of boiler that captures heat from hot flue gas or process exhaust. Unlike a conventional boiler, it does not depend mainly on direct firing. Its job is to recover thermal energy and convert it into steam, which can then be used in the plant. WHRBs are widely used in industries where high-temperature exhaust gases are available. In cement plants, kiln exhaust can be recovered. In steel plants, furnace gases can be utilized. In gas turbine plants, the same idea becomes an HRSG, heat recovery steam generator. The hot gas enters through the inlet duct and passes across heat transfer surfaces. Water inside the tubes absorbs heat and turns into steam. The steam drum separates steam from water. The economizer preheats feed water, and the superheater raises steam temperature if superheated steam is required. The working principle is simple. Hot exhaust gas flows through the boiler chamber. Water flowing through the tubes absorbs this heat. As the water temperature rises, it converts into steam. This steam is then used for process heating, turbine operation, or utility services. To determine fuel saving, first we calculate how much heat is available in the exhaust gas. This is done using the formula Q equals mass flow rate into specific heat into temperature drop. The greater the flow and the higher the temperature, the greater the recovery potential. Once the recovered heat is known, we calculate how much steam can be produced. We divide the available heat by the enthalpy rise needed to convert feedwater into steam. In this example, the WHRB generates about 4.76 tons of steam per hour. This is the most important part. If the same steam were produced in a conventional fired boiler, fuel would be needed. Since the WHRB is already producing that steam, the equivalent fuel is saved. In this example, the saving is about 366 standard cubic meters of natural gas every hour. When this hourly fuel saving is extended over an entire year, the impact becomes huge. At 8,000 operating hours and a gas cost of 45 rupees per standard cubic meter, the annual fuel saving becomes around 13.18 crore rupees. At the same time, carbon dioxide emissions are reduced by thousands of tons. WHRBs offer excellent economic and environmental benefits, but they also require proper design and maintenance. Dust can foul heat transfer surfaces, corrosion can damage tubes, and pressure drop must be controlled. So, good operation and maintenance are essential for long-term performance. A waste heat recovery boiler is one of the smartest energy-saving systems in industry. It captures heat that would otherwise be lost and converts it into useful steam. With correct calculation and design, it can deliver major fuel savings, lower costs, and reduced emissions. In short, it turns waste into value.